Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 2, Section 3, Solving Multi-Step Equations. So the last section we solved equations with only one step involved. So we're going to move on to how to solve equations with more than just one step. So why would we learn about this? Okay, here's an example of why. The Tour de France is the premier cycling event in the world. The map shows the 2007 Tour de France course. If the length of the shortest portion of the race can be represented by k, the expression 4k plus 20 is the length of the longest stage, or 236 meters. Okay, so 4k plus 20 is representing 236 kilometers. Okay, solve multi-step equations. The situation above can be described by the equation 4k plus 20 equals 236. Because this equation requires more than one step to solve, it is called a multi-step equation. To solve this equation, we must undo each operation by working backward. Okay, that means we're going to just do the opposite to get rid of everything else. Remember, we're going to isolate the variable by itself. So if the variable is k, we want k equals a number is what we're trying to do here. Okay, so how would we do this? Right, so here's an example of a multi-step equation. It says 11x minus 4 equals 29. We're going to solve this equation. So if you've had me in previous classes, what I like to do is just circle the term with the variable, because I know I'm going to get rid of what's next to it first. Okay, so when we're solving these multi-step equations, you're going to first add or subtract. Okay, so this is minus 4. So in order to get rid of that minus 4, we're going to do the opposite, which is plus 4 on each side. Remember, what you do to one side, you do the same to the other side. So when we do that, that gets rid of the negative 4 on the left side. You have 11x equals 29 plus 29 plus 4 equals 33. Now you have 11x equals 33. This 11x means 11 times x. So the next stage you're going to do is either multiply or divide by the same number on each side. So in this case, it's going to be 11. So we're going to divide by 11 on each side. 11 divided by 11, you get isolated, you have 1. 33 divided by 11 equals 3. So your final answer should be x equals 3. Okay, here's another example on how to solve two multi-step equations. So here you have 8 plus 7, and this entire thing is going to be divided by 8 equals 5. So the opposite of dividing is multiplying. So we're going to get rid of this 8 on the bottom by multiplying by 8 on each side. And that gets rid of these 8's here. So 8 divided by 8 is 1. So that gets canceled out. What you have left here is 8 plus 7. 8 times 5 is 40. Okay. Next, you're going to subtract the 7 because it's plus 7. So the opposite, you're going to subtract 7 on each side because 7 plus 7 cancels out. Now you have a equals 40 minus 7 is 33. Your final answer is a equals 33. You can check your solutions by substituting the results back into the original equation. That means 33. If you put it back in here, does it equal 5? If it does, that means you did it right. So 33 plus 7 is 40 divided by 5 does equal 5. So you did the problem right. So that is the correct answer. So here's your turn, number 1A and 1B. So this is the time to pause the video and do numbers 1A and 1B and come back when you are done. Okay, welcome back. We're going to try a real world problem this time. Okay, so real world link. Shoppers in Shanghai, China can pay for purchased items at a terminal that can match the buyer's fingerprints with their bank accounts. So that's pretty cool. So I guess in Shanghai, when you buy something, you just put your finger right there and they'll read your fingerprint and they'll link to your bank account. Okay, so if you were in Shanghai and shopping, okay, here is Hiroshi buying a pair of water skis that are on sale for 2/3 of the original price. Okay, 2/3 of the original price. After he uses a $25 gift card, the total cost before the taxes is $115. What was the original price of the skis? Write an equation for the problem, then solve the problem. Okay. So you have 2/3 of the price. So you don't know what the price is, so they put P for price. So 2/3 of that, 2/3 times P, minus the $25 gift card equals $115. So you have here 2/3 P minus 25 equals 115. Okay, so 2/3 P is what you're going to isolate. So you're going to add 25 to each side to get rid of the 25 here. Now you have 2P equals 140. Now if you like, we can write this another way. Instead of going sideways, you can put 2/3 P minus 25 equals 115. And then you can write it so it's up and down. So plus 25 here, and then plus 25 here. Okay. Let's cancel. Now you have 2/3 P equals 140. Okay. You can write it sideways or up and down. And that's what we got here. So we have 2/3 P. In order to get rid of a fraction, you need to multiply each side by the reciprocal. The reciprocal is just the upside down number. So 2/3 multiply each side by 3/2 on each side, because 3 and 3 on top and bottom cancels out. 2 on the top, 2 on the bottom cancels out. Now you have P by itself equals 3/2 times 140. So you can do 3 divided by 2 times 140, or you can do 3 times 140 divided by 2. Either way, you get the same answer, 210. Original price was $210. Here's your turn, number 2A and 2B. So go ahead and stop the video, do those two problems, and come back when you are done. Okay, welcome back. Okay, we're going to solve some problems involving consecutive integers. Consecutive means right after another, one after another. Consecutive integers are integers in counting order, such as 4, 5, and 6. So n plus 1, n plus 2. There'll be 3 numbers in order. So counting by 2s will result in consecutive even integers if the starting integer n is even, and consecutive odd integers if the starting integer n is odd. So consecutive integer, you have n, n plus 1, n plus 2. That's 3 numbers in order. Okay? Consecutive even integers means you have the original number, and then you're going to skip a number, n plus 1, so you're going to go to n plus 2. And you're going to skip every other number. So the next number is not n plus 3, but n plus 4. Okay? Now, it's the same thing when it comes to odd integers, because whatever number you start with is going to be an odd number. So you're going to skip n plus 1, you're going to go on to n plus 2. So you're skipping every other number. So even though this one is even and this one is odd, your symbols are going to look the same. Okay, because your n, starting number n, will be even, and your starting number here, n, will be odd here as well. Okay, so a quick study tip, representing consecutive integers. You can use the same expression to represent either consecutive even integers or consecutive odd integers. That's exactly what we just talked about in the previous slide. It is the value of n, odd or even, that differs between the two expressions. Okay, so let's solve a problem that involves consecutive integers. Number 3. Write an equation for the following problem, then solve the equation and answer the problem. Find 3 consecutive odd integers with the sum of negative 51. So if you start with n, okay, your next consecutive odd integer will be n plus 2. And then the third one will be n plus 4. So you have these 3 integers, n plus 2, n plus 4. So these 3 numbers added is going to equal negative 51, because they said the sum equals negative 51. So here all we're going to do is add all these together. So you have n here, and another n here. That makes 3n. So you have 3n. Okay. And the numbers you have 2 and 4. 2 plus 4 is positive 6, equals negative 51. What they did next is, to get rid of the 6, they subtracted 6 on each side. So that's gone, and you have 3n equals negative 57. 3n means 3 times n, and the opposite will be division. So we're going to divide each side by 3. And now you have n by itself, and you have negative 57 divided by 3, which is negative 19. So your first integer is negative 19. Your next integer, plus 2, is negative 17, and then negative 15. So those are your three numbers, the three consecutive odd numbers, negative 19, negative 17, and negative 15. Okay, so here's your turn number 3. So go ahead and do number 3. And this is the last slide. So when you're done with number 3, make sure you put your homework away, put it in your homework binder, so bring it back to school so that you can get credit for your homework. Okay, thanks for watching.